Hello dear students, how are you all? I hope you all are in the best of your health and enthusiastic about your studies. Students, today we are going to study chapter number 5 of class 10 science, that is periodic classification of elements. So first of all, let us see what we have already studied in previous classes. How elements are formed, what are atoms, how can we write electronic configuration of an atom. We all know these things because we all have studied this in our previous class. Now, let us see what we are going to discuss in this chapter. Early attempts in the classification of elements by Dobereiner and Newlands, Mendeleev's periodic table, modern periodic table and trends in modern periodic table. We are going to study all these topics in detail. So let us start. We know all the elements have different properties. It is not easy to study all the elements one by one. So scientists started looking for some patterns in their properties, on the basis of which they could study such a large number of elements with ease. So many scientists like Dobereiner, Newland, Mendeleev have proposed different ways for the classification of elements. So dear students, let us start with Dobereiner's triads. In the year 1817, Dobereiner tried to arrange the elements with similar properties into groups. He identified some groups having 3 elements each and called them triads. According to him, when elements are arranged in order of increasing atomic masses, groups of 3 elements are obtained, in which the atomic mass of the middle element is average or mean of the atomic masses of the other 2 elements. For example, his one triad was consist of lithium, sodium and potassium with the respective atomic masses 6.9, 23 and 39. Here we can verify that the atomic mass of sodium is arithmetic mean of the atomic masses of first and third element of triad. 6.9 plus 39.1 divided by 2 is equals to 23. Dobereiner's classification was helpful in classifying some of the elements, but it had some limitations. Dobereiner could identify only 3 triads from the elements known at that time. Hence, this system of classification of elements into triads was not forced to be helpful. Now, dear students, let us learn about Newland's law of octaves. According to Newland, when elements are arranged in order of increasing atomic masses in a row, the properties of the 8th element are repetition of the properties of the first element. It was just like in musical notes. In music, when we sing sa, re, ga, ma, pa, dha, ni, then the 8th note is sa again, which is repetition of the same note after the gap of 7 notes. For example, the properties of lithium and sodium were found to be same, and sodium is the 8th element after lithium. But Newland's classification also suffered from certain defects or limitations. First of all, it was found that the law of octaves was applicable only up to calcium. Second, it was assumed by Newlands that only 56 elements existed in nature and no more elements would be discovered in the future. But later on, several new elements were discovered and their properties did not fit into the law of octaves. Third limitation of Newlands was that in order to fit elements into his table, Newlands adjusted two elements in the same slot. Also, he put some unlike elements under the same slot. For example, cobalt and nickel are placed in the same slot and these are placed in the same column as fluorine, chlorine and bromine, which have very different properties. Now, let us discuss Mendeleev's periodic table. After the rejection of Dobereiner's and Newland's arrangement of elements, Mendeleev gave the first systematic classification of elements, which was based on well-defined periodic law. In his table, elements were arranged on the basis of their fundamental properties, the atomic mass, and also on the similarity of chemical properties. According to Mendeleev's periodic law, the properties of elements are the periodic functions of their atomic masses. But Mendeleev's periodic table also had some limitations. First of all, there was no fixed position given to hydrogen in that periodic table. Second limitation was that the position of isotopes could not be explained. Isotopes are the atoms of same element which have same atomic number but different atomic masses. So, when isotopes were discovered, they face a challenge to Mendeleev's periodic table. Third limitation of this table was that the atomic masses do not increase in a regular manner in going from one element to the next. So, it was not possible to predict that how many elements could be discovered between two elements. Beside these limitations, there was some achievements of Mendeleev's periodic table. Mendeleev left the gaps for future elements to make the periodic table systematic. He even predicted the properties of future elements in advance and even named them by adding prefix eka. For example, he named gallium as eka aluminium, which was discovered later. To ensure that the elements having similar chemical properties should come in the same group, he placed an element with a slightly greater atomic mass before an element with a slightly lower atomic mass. Noble gases were discovered very late because they are very inert. But when these gases were discovered, a new group called zero group was added without big alternation in the Mendeleev's periodic table. So, these are the achievements of Mendeleev periodic table. Now, let us see modern periodic table. In 1913, Henry Moseley found that the atomic numbers of the elements are the more basic fundamental property than their atomic masses. So Mendeleev's periodic law was modified by Moseley as modern periodic law, which states that the properties of the elements are the periodic functions of their atomic numbers. So when we arrange elements in order of their increasing atomic numbers, only one electron or one proton increases, whereas atomic masses do not increase in a regular pattern. Dear students, let's learn some important points about modern periodic table. The anomalies in Mendeleev's classification was sorted out in modern periodic table. Hydrogen was given a specific place according to atomic number. Elements were classified on the basis of their similar chemical properties. The basis of modern classification of elements was atomic number, which is a more fundamental property. Let's have a look to modern periodic table. Electronic arrangement in elements. We have studied electronic configuration and structure of atom in class 9th. We all know that there is a nucleus in the center of the atom and K, L, M, N, etc. shells are present outside the nucleus. Maximum number of electrons present in any shell depends on the formula, that is 2n square. Here n is the number of given shell from the nucleus. For example, first shell outside the nucleus is K shell. So for K shell n will be 1. So according to formula 2n square will be 2 into 1 square, that is 2 into 1 is equals to 2. Like this we can conclude that K shell may contain 2 electrons and hence the first period has 2 elements. Second shell is L shell. So according to formula 2n square for L shell will be 2 into 2 square, that is 2 into 4 is equals to 8. It means there will be 8 electrons in L shell and hence second period has 8 elements. Similarly, third shell is M shell. So for M shell, if we apply formula 2n square, it will be 2 into 3 square is equals to 2 into 9, that is equal to 18. But the outermost shell can have only 8 electrons. So the third period also has only 8 elements. The position of an element in the periodic table tells us about its chemical reactivity. Dear students, let's see the electronic arrangement in sulfur. Atomic number of sulfur is 16. It means it has 16 protons and 16 electrons. Now, if we divide these 16 electrons in their respective shells, then arrangement will be like this. K shell will have 2 electrons, L shell will have 8 and M shell will have 6 electrons. So, electronic configuration of sulfur is 2, 8, 6. Outermost shell of sulfur contain 6 electrons. Now dear students, let us see some trends in modern periodic table. So first of all, the valency. The valency of an element is determined by the number of valence electrons present in the outermost shell of its atom. Let's see how can we calculate the valency of an element from its electronic configuration. Let us take magnesium and sulfur for example, and their atomic numbers are 12 and 16. First of all, magnesium, its atomic number is 12 and electronic configuration is 2, 8, 2. It has 2 electrons in its outermost valence shell. To obtain its octet condition, it loses 2 electrons and obtain its octet, a stable condition. So, valency of magnesium is 2. Now, let us talk about sulfur. Its atomic number is 16 and electronic configuration is 2, 8, 6. To get stable, it needs 8 electrons in its outermost shell. For this, it can either donate its 6 electrons or can gain 2 electrons from other element. So, sulfur gain 2 electrons and get stable condition by attaining 8 electrons in its outermost shell. Therefore, the valency of sulfur is 2. When we move from left to right in a period, valency of elements increases from 1 to 4 and then decreases to 0. Whereas, when we move down in group, the valency of elements remains constant. Atomic size. Now, let us discuss about atomic size in periods and groups in modern periodic table. When we look to the elements present in second period of periodic table, there are lithium, beryllium, boron, carbon, nitrogen and oxygen elements are there. If you look carefully, you can observe that number of electrons in the valence shell increases and number of protons in the nucleus also increases. It results in the increase of nuclear charge. So, due to increase in attraction force in between electrons of valence shell and nucleus, the size of atoms become small. So, in periods on moving from left to right, size of atom decreases. Atomic radii of different elements present in second period is given here, and it clears that on moving from left to right in period, the size of atoms decreases. Now, let us discuss about atomic size in groups. Dear students, if you have a look to the elements present in first group, you will see hydrogen, lithium, sodium, potassium, etc. are there. The size of atom increases on moving down in a group. This is because of increase in number of shells in each element. This increase the distance between the outermost electrons and the nucleus, and the force of attraction exerted by nucleus on electrons becomes less effective. Hence, the atomic size increases. Here you can see the change in the atomic radii of different elements present in first group, which is increasing from up to down. Dear students, let us discuss about metallic property. The tendency of elements to lose electrons and acquire positive charge in measured in terms of metallic character. More easily the element loses the electron, more metallic will be the element. As we move from left to right in a period, atomic radius decreases. Due to increase in effective nuclear charge, the force of attraction exerted by the nucleus on electrons of various shell increases. So, it becomes difficult to lose electrons and hence the metallic character decreases from left to right in a period. Whereas, in groups, when we move down, size of atom increases and the effective nuclear charge experienced by the valence electrons is decreasing because the outermost electrons are farther away from the nucleus and removal of electrons becomes easy. Hence, the metallic character increases down a group. Now, let us discuss non-metallic character. It is opposite to the metallic character. In periods on moving from left to right, non-metallic character increases, whereas down in group it decreases. So, dear students, let us see what all we have discussed in this chapter. Elements are classified in order to study them with ease. Dobereiner and Newlands classified elements on the basis of their atomic masses. Mendeleev's arranged the elements in increasing order of their atomic masses and also according to their chemical properties. In 1813, Henry Moseley arranged elements in order of increasing atomic numbers, taking it as a fundamental property of the element. According to modern periodic law, properties of elements are a periodic functions of their atomic numbers. Elements arranged in modern periodic table show periodicity of properties including atomic size, valency and metallic and non-metallic characters. Dear students, now let us discuss some questions and I hope you all know the answers well. First question, what is the electronic configuration of oxygen? Its atomic number is 8 and your options are 2, 6, 2, 5, 1, 4, 3 and 2, 8. Yes, the correct answer is 2, 6 because this atomic number is 8. Therefore, 2 electrons in K shell and rest 6 electrons in L shell. How many periods and groups are present in modern periodic table? And your options are 7 periods 18 groups, 7 periods 19 groups, 7 periods 20 groups or 8 periods and 20 groups. Yes, the correct answer is 7 periods and 18 groups. Now, I have some extra questions for you to think and note down in your notebooks. The questions are, first of all, what are the limitations of Mendeleev's periodic table? And question number 2, how valency of elements changes in modern periodic table? Try to write answers of these questions in your notebook. So, in this way we have seen that how so many elements are classified by different scientists, how they have given their classification, and now these days we are following modern periodic table. So, here we come to an end of this chapter. I hope you all have learnt it nicely. You all keep studying, be safe and be happy. Thank you.